Today, we're diving into a revolution that's happening right now in our hospitals, a revolution driven by AI. We're going to look at how UCSF is building these incredible tools that could totally reshape healthcare as we know it.
Think about it. In any high-stakes medical situation, every single second is critical. Doctors have to make life-or-death decisions, often with a mountain of information and just no time. But what if the thing slowing them down the most isn't the patient, but the technology that's supposed to be helping?
And that's the crisis we're facing in medicine today. You see, the electronic health records that were meant to make things easier, they've turned into this massive clerical nightmare. Doctors are literally drowning in data entry, and it's causing record-high burnout and taking them away from what actually matters, the patient.
So this is the big promise, right? The core of the AI revolution in medicine. It's not about replacing doctors. No way. It's about empowering them. What if AI could sort through all the noise, find that crucial signal, and give clinicians the one thing they can never make more of? Time.
Now, to really get why these new AI tools are such a big deal, you have to understand the scale of the problem. For a doctor today, it's not just about too much information. It's about trying to find one life-saving piece of data in an absolute storm of digital chaos. I mean, just look at this list. This is the daily reality. A patient's data is scattered all over the place. The EHR systems are often slow and just clunky. When you're under pressure, it's so easy to make a small error in a manual calculation, and the old systems, they throw off so many alerts that doctors get what's called alert fatigue. They start tuning them out, which is terrifying. And what's the end result of all this friction? Critical diagnoses get delayed.
Okay, so what's the solution? Well, it's not just a tiny improvement. We're talking about a fundamental shift in how fast and how smart these systems can be. Let's call it the 10x speed paradigm.
Let's just put it side by side. The old way is kind of like using a basic calculator. The doctor has to manually dig through a chart, find a dozen lab values, and type them all in. It's totally disconnected from what's happening with the patient right now. The new way? It's alive. The AI pulls data straight from the live chart, uses predictive models to see what might happen next, and does it all inside one system. It is a total game changer.
And listen, this isn't just a theory. A recent study actually confirmed it. Generative AI can analyze these super complex medical datasets 10 times faster than a team of human experts. Think about that for a second. Not 10% faster, 10 times. For someone having a stroke, that kind of speed can mean the difference between a full recovery and a permanent disability.
So how does this 10x speed actually work in the real world? Well, let's meet the new AI assistants that UCSF has been building. These aren't just ideas on a whiteboard. They are highly specialized tools doing critical jobs right now.
All right, first on the list is Foghorn. You know how hard it is to find the right patients for a new drug trial? It's this super slow manual process of reading through thousands of patient charts. It's a huge bottleneck. Foghorn is built to fix that once and for all. So how does it work its magic? It uses this really cool technique called Retrieval Augmented Generation, or RAG for short. The best way to think about it is it's like giving the AI a perfect photographic memory of an entire medical library. It can read and synthesize all of that information in milliseconds, then scan a patient's chart to find the perfect trial match. It's unbelievably fast and accurate.
Okay, so from the careful world of research, let's jump right into the chaos of the emergency room. When a trauma patient comes in, the #1 priority is figuring out if they have internal bleeding. Every second counts.
And this is where Fast AI steps in. FAST is an acronym for a type of bedside ultrasound. The AI analyzes those scans and can spot internal bleeding with a staggering 98% accuracy. This gives the ER team an almost instant diagnosis right there at the bedside, without that agonizing wait for a radiologist to become available.
And the last tool we'll look at is Bridge. This one tackles a different kind of problem. Not just speed, but complexity over time. A single patient's medical history can be this dense, confusing mess of notes and lab results going back years. How is a doctor supposed to make sense of it all quickly?
Well, Bridge basically acts as a translator. It takes all that dense text and turns it into clear visual patterns. It can create these beautiful timelines of a patient's entire health journey, use color-coded heat maps to show where the risks are, and it pulls in everything: X-rays, genomic data, you name it. It lets a doctor see the whole story in a single glance. That right there is the foundation of true precision medicine. Okay, of course, with all of this incredible power comes a huge responsibility, right? If we're going to ask doctors to rely on these tools for life and death decisions, they have to be safe, they have to be private, and they have to be trustworthy.
One of the really smart ways UCSF builds that trust is with something called federated learning. Think of it like this. Instead of all the sensitive patient data from different hospitals being sent to one central computer, the AI model itself travels to each hospital. It learns from the data right there, on site, and then only takes the lessons, not the private data, with it. So the AI gets smarter and smarter without ever compromising a single patient's privacy.
And this isn't just some side project. This commitment to trust comes from the very top. Dr. Atul Bhatnagar at UCSF puts it perfectly. The goal isn't just to use AI. The goal is to lead the world in using trustworthy AI. That focus on safety and ethics is absolutely non-negotiable.
So these are really the pillars holding everything up. It's a whole strategy. You've got strict rules for AI safety, you always keep a human expert in the loop to validate things, you use clever tech like federated learning to protect privacy, and you build on open, transparent foundations.
So where is all this headed? What's the big picture? Because this is about so much more than just making today's hospitals run a little bit better. This is about completely changing what healthcare even means.
And you can see this didn't just happen overnight. The momentum has been building for more than a decade. From starting their digital health center way back in 2013 to launching big programs and partnerships, this has been a long-term, deliberate mission. The breakthroughs we're seeing today are really just the result of years and years of laying the groundwork.
And that right there is the ultimate goal. This is the real paradigm shift. We are moving away from a reactive model of medicine, waiting for you to get sick and then treating you, to a proactive, predictive model. Using AI to constantly analyze data and spot the warning signs of a disease days, weeks, or maybe even years before you ever feel a single symptom.
Which leads us to one last big question to think about. When the watch on your wrist, powered by this kind of AI, can predict a heart attack days before it happens, it changes everything. It changes your relationship with your doctor, with the hospital, and with your own body. So you have to ask yourself, in that world, are you still just a patient? Or do you become the CEO of your own health?